Hello, supply chain designers, and welcome to our first Hangout session. I'm Sergio Caballero, the course lead, and I'm very pleased to have Dr. Chris Kaplis here with me. Welcome, Chris. Dr. Chris Kaplis is the Executive Director at the MIT Center for Transportation and Logistics, and he's also the instructor of our course. Okay, before getting started, let me give you some statistics about the course. We have more than 20,300 students already enrolled in this class. The median age of our students is 30 years.
Wow, that's older than normal, isn't it? That seems
Yeah,
older.
I think so. I think so. 24% of our students are women, and our students represent more than 180 countries all over the world. The top 3 countries with most students are the US with 19%, India 11%, and Brazil with 3%. Okay, this is the third time that we are running SC2x, and the course has been redesigned. So now the course, we have 8 weeks of content, 2 off weeks, 1 midterm and 1 final. Nothing new for those who have already taken SC0 and SC1x.
Yeah, so it's following the identical pattern of SC1x, which the majority of you have probably already taken, and that we have, what the problem was before, they were never originally designed to have a midterm or a final, and we didn't want to have a homework grade assignment overlapping with a final. That's why we put in that breather week and week 5, and then it'll also be week 11. And so we always have a week before the tests for you to catch up. And I think the structure works well, but we'd love to get your feedback.
Excellent. So let me address the agenda for this session. I'm going to start asking Chris some questions, some general questions about the course. Then I will read some of your questions, guys. So please, now is the time. Write any question that you might have. I'm going to read later. Then we'll have a breakout session, and we already posted the instructions in the week 2 material. And you will have between 10 to 15 minutes to come up with some solution to that particular problem posted. Great. After that, we will we'll read your answer, and if time allows, we'll again have some Q&A session. Okay. So let's get started. So Chris, this first Hangout is open to all the students.
Oh, okay.
Also to all the students. So let me ask you this question: why an audit student that is taking SC2x should start thinking to become a verified student?
Yeah, so there's so the underlying or the overarching reason why we created these courses, mainly pushed by President Raphael Reif and the director of the Digital Learning Center, which is Professor Sanjay Sarma, is to educate the world for free. So everything will always be there for free: the videos, the practice problems, the quick questions, and some assessment graded questions, as well as a midterm and a final. So it'll always be there for free to educate. However, the credentialization is something different. That takes more work. And that's, if you're verified, you'll get credentialization. So if you just want to educate yourself, pick something up, then fine. The audit is fine, and it'll always be there for you. However, we found that in addition to being credentialized, there are other benefits when you become a verified student. And becoming verified requires 2 things. One, there's a charge of $150 per course. And 2, you have to be ID verified. You have to show ID and have a picture taken of yourself so we can validate that you're the person actually doing the work. So other benefits from this, besides having a credential that you can use on LinkedIn, your resume, and elsewhere, it's also being accepted by other universities, to include MIT and other universities around the world. Also, we found that if you're a verified student, you tend to do better. You tend to stay more engaged. There's a phrase, if you have skin in the game. So it seems like if you pay a little bit of money, you're more engaged. Verified students typically do much better than audit students. They stay longer. They do more of the work. Also, what we try to do to encourage verified students, we have a section each week that's called the supplemental materials for MicroMasters students. Because if you're verified, we assume you're on the path for the MicroMasters credential. And so what we put in this separate area that's only accessible by people who are verified are supplemental materials. Now, these aren't things that you have to do in order to pass the course, because all that's free for the audit students as well. These are supplemental things like theses that have been done up here that are relevant to that week's topics, additional problems. Sometimes we'll have interviews or videos, but they're things to kind of round out and give a little extra value to those students who are actually supporting the efforts as well. So you get the credentialization, you get access to additional materials. You also get access to Hangouts like this. After this Hangout, only the verified students will be allowed to come in. And again, we're just trying to incentivize people to become more verified for a couple of reasons. One is we want to become sustainable financially so we can keep doing this because someone has to pay our salaries. But the second is it makes you a better student if you're verified. You'll do better. And so that's why we're trying to encourage people to become verified.
Yeah.
Whether you want to go through the whole MicroMasters credential and come here for a master's degree or just want this one course, it's a better way to take the course.
Excellent, Chris. Thank you. So I'm new in MicroMaster, but something that surprised me was the results that we get from SC2x. 80% of the students that have completed the course are verified students. I think something. This is the data that supports what you were claiming.
Yeah.
Okay, so we have delivered already 2 weeks of content. All of it was about the network design.
Right.
But what should the students expect for the rest of the course?
Yeah, so because of the redesign, we didn't have an overarching video to show you where it's going. You can actually look at the syllabus and get that, but let me give you a rough idea. Everything with a supply chain design, SC2x, is all about the design of the 3 major flows, right? There's the physical flow, the information flow, and the financial flow. We start with the physical flow. And for the physical flow, our primary tool is mixed integer linear programming for supply chain network design. It's the standard approach used by every company, every consultancy out there. What we've done in the last part, I think week 2, lesson 2, we talk about some advanced topics. Right?
That's right.
We covered those. And so different ways that you can also use that tool for other purposes or how to enhance that. Because as we all know, mixed integer linear programs are deterministic, right? And so you can't handle uncertainty very well, although we give you some workarounds, how to do robust optimization and do different runs. But that's the physical flow. Next, we'll move in to some of the information flow. And we're going to start from the production information going to the customer. And that's because the tools you use to plan your production schedule are the same exact tools that you use to do your supply chain network design. In fact, the only difference is you add a time element. Remember, for strategic network design, it's usually a single period and it's fixed. If I do multiple periods where inventory, I need to know the inventory position at each point in time, I'm essentially creating a production planning schedule, which we'll talk about. And that's what we talk about in week 3. You can continue this on further to understand the information flow from your company to your customers by doing aggregate planning. And aggregate planning is something we'll cover in week 4. Again, using a mixed integer linear program to see what's the effect of running a promotion where it changes the demand. What's the effect of changing my capacity at my plant or my labor hours? So the same methodology, mixed integer linear programming, large scale optimization, is used to map and coordinate the information flow from manufacturing to distribution to your customers. So we do the physical flow, then we start doing the information flow, then we're gonna have a midterm. After that, we continue the information flow, and we actually go backwards a little bit. We talk about how you can interact with your supplier. And the reason why we shifted that is because in SC2x, in week 6, when you take your midterm, you're at the exact midpoint of the entire program. You've taken 0, SC1x, and half of SC2x. And up to that point, everything's been very quantitative and mathematical. Everything's a model. Starting with the second half of SC2x into SC3x and 4x, it gets a little more qualitative. And so there's a lot more softer things that are being considered. The models are still there, but there are other things that are being considered. So what we start afterwards, after the midterm, is how do you deal with your suppliers, sourcing, those kind of things. And then we'll go into a 2.5 to 3 week segment on finance, specifically looking how supply chain ties in to financial decisions. Well, because when you work in supply chain, you're talking about physical metrics. When you talk in the language of the CFO, the chief financial officer, you need to talk in terms of dollars. And so we'll talk about that translation, do kind of a mini course on supply chain finance. And then we'll finish up with organizational design. So essentially what we're doing is physical flow, design of physical flow, design of information flow, design of the financial flow, and then we finish with organizational design. How should you structure your supply chain organization? And we'll capstone that with a case study, which is probably one of the first ones that we've done here. in this course so far. But that kind of gives you the big picture. Everything's about the design of the 3 flows.
Excellent. Thank you. Thank you for the answer, Chris. So many of our students, Chris, have already taken SC0 and SC1 and X, and most of them are familiar with SAS or AMPO. So my question to you, Chris, is why is this course taught using primarily spreadsheets?
Yeah, so we did SC2x. This is its 3rd run, and we did this prior to doing SC0x when we decided to offer more software solutions. There's no easy way to do this. And so originally when we did these courses, SC1, 0, 2, and 3, we assumed we were going to stay in Excel, because the nice thing about spreadsheets, Excel, LibreOffice, Google Sheets, is it can do a little bit of everything pretty well. But as we all know, it doesn't do certain things larger scale very well. It has issues and limitations. And so when we redid SC0x for the first time in the fall, and have run it again now in the middle of running it again, we gave the option to students to use a wide range of software packages. And you can still use all those packages. If you have to do a linear program, and I show how to do it in Excel, you can do it in AMPL. You can do it in R if you want. You can do it in CPlex if you want. The answer for any of the problems will be the same. No matter what package you use, assume it's an okay package. But I kept the spreadsheet stuff in there just because it's simple. It's another way to look at it, because we didn't show you how to do it in Excel or LibreOffice prior to this. We took that out of 0. So assume it's just a complement. And the thing that I like about doing it in a spreadsheet that you don't have in SAS or in AMPL, you don't see the constraint matrix. I love seeing the constraint matrix. And so to me, whenever I think of a problem, I think of it visually as a constraint matrix. And so you can think of it where you're going to have an identity matrix, what your binary variables look like. To me, it makes total sense when I can have the columns. And so I'm very comfortable seeing it in that view, because that's how I grew up, not doing it in Excel, but being able to map out the matrices. However, you can use any tool you want. So don't think that you have to use Excel for this. You can use SAS or AMPL for any of these, and you've already done all of these in SC0x. You've done transportation problems, you've done transshipment problems, you've done mixed interlinear programs. So it's all the same. You can reuse some of those models or those approaches to solve every one of these problems.
Okay, thank you, Chris. And what you prefer, Chris? What do you usually, software do you use to solve the practical problems?
Yeah, I haven't, if it's something small, I'll slap it in Excel in 30 seconds. I'll do that really quick. I've done that for a bunch of things. I created a little quick optimization to assign students to something, and I did it in like 20 minutes, Excel, because it was easy. For something larger scale, like if we have a project, we tend to use CPlex, which is something a little more, it has a huge license fee, and also it solves bigger problems. It's more production level. And so for larger projects, we'll use CPlex. For me, just messing around with something, I'll just use Excel. But we've used other things. You can also have add-ins for Excel that can make it much bigger. There's an add-in called, what's it called? Open source? What's the new? For Solver. What was it called?
Yeah, but it doesn't work on Mac.
So you have to look around, but there are some open source ones. Sadly, nothing works on a Mac. That's one of the biggest problems we've had. I love Macs, but they have issues. But there are other solvers out there. So I don't do a ton of coding myself these days anymore.
Okay.
But you should answer that question. What's your favorite optimization tool?
So in my case, I use a lot of Python for all the modeling.
Okay.
Okay. And to solve the problem, the solver that I tend to use is Groovy. But again, you'll need the license to that.
Yeah.
Okay.
So, but the important thing is to do that, you have Python surrounding it. So if you're going to do this in production, you're not going to enter the things in by hand like we typically do. For these kind of simple problems, you'll have code surrounding it that will take an input matrix and output a matrix. Okay.
Okay, so we have some questions from the students.
All right.
So let me read the first one. So how to balance the science and art effort? A model can be built very complex and require many hours to be built. Okay, so how do you balance this science and art about the network design?
Yes, you need to balance it. Yeah, I mean, it's an open-ended question. So I think one of the challenges that you face when you have an optimization, it's easier now than it used to be. When I was doing a lot of this work and coding myself in the late 80s, it was hard to do a lot of this. Now it is so easy to have an optimization model that's massive. So you have this yearning to try to create these really complex, detailed strategic models. The problem is you can't execute them. And we'll talk more about that when we talk about combinatorial auctions in week 7 and 8, I think, with procurement, where you can have this really intricate solution, but it can't be executed. So it's a judgment call. The science can be taught very quickly. We can teach you the science, and we'll talk about that during your question. The art of when is too much, and how to apply that, that's a challenge. And that usually requires judgment for the context, to understand when you're going too far. Similar when you guys did like regression. You don't always try to go for that highest R² value, right? You want to find something that gives you a reasonable answer. And unfortunately, when students are doing this for the first time, they have zero context, so they don't know how to have that. That's why it's helpful to have people who've been seasoned, and they can start tempering when the judgment comes. I can't teach you art. You have to experience that, in my opinion.
Okay, excellent. I think it's now time to go through the breakout rooms.
Okay. Can I read the question then?
Please,
is that okay?
please.
Okay, I'm gonna put my glasses on because I'm getting old. Okay, so what we asked, and they have this already?
Yes.
Okay, so the big thing I wanted to do for this is, this question that was just asked is a perfect example. You're balancing this art and science, because we know the math works, but the math works under a lot of assumptions that don't always apply. So the question I wanted to ask you guys is, take a look at the real world now. And over the last 12 months, we've seen a lot of surprising political events, election results. Brexit, they voted to leave the EU in June of last year. Donald Trump was elected president. That was totally unexpected. He went on a platform of building a wall and trying to reduce the amount of global trade. And to be honest, his opponent, Hillary Clinton, was also leaning against global trade too. So that was another interesting twist. And France's second-round presidential elections in 2 weeks, and you couldn't ask for more polar candidates. You also have uncertainty happening in Turkey. You have uncertainty happening in China right now. There's a lot of political uncertainty. So the question is, if I give you a hypothetical company that's operating in Europe, and you currently have manufacturing in a handful of countries and you distribute throughout, and you're being asked to come up with a potential supply chain design plan for the next 10 years, what would you do to try to represent or capture some of this uncertainty or to guard against it? Because you don't know what's going to happen in 10 years or over the course of 10 years, but companies have to make decisions that they can't change quickly. And so what I want you guys to do is, in your groups, come up with like 3 things, no more than 3. Bullet point them so we can read it. Don't write essays. Just make it short. Think like you're using Twitter. Think like the president, right? Come up with something short, but what would you do for the network design problem? Okay, and what are the 3 things you would do differently? And let's talk about it, because this is a real problem. And I'll talk about a real case that's happening now. So what do they have, 10 minutes?
So they will have 15 minutes?
15 minutes.
And
Well, 15 minutes.
Yes, 10.
There we go.
Okay.
10 and 5. All right. See you in 15.
See you in a bit.